In this module, we're going to do a little quiz, and there are some visual angle calculation questions. And so you can work through the questions on the next slide, and then I will review the answers, and you can see how you do. So good luck. So pause the video here and try these questions. When you have the answers, start the video again to see the answers on the next slides. So for question number 1, the question asks, if the check size is measured to be 8 millimeters and a patient is sitting 1.5 meters from the screen, what's the visual angle subtended in minutes of arc and then also in degrees of arc? And so to calculate the answer, we start off by writing down our different variables. And so we know that the width of the check is 8 millimeters, and it's already in millimeters, so we don't have to convert anything. And then the second variable, distance of the object to the eye, is given as 1.5 meters, which we have to convert to 150 centimeters, which is also 1,500 millimeters. We're going to use the formula for small check sizes, which is A, the visual angle, is equal to 3,438 times W, all divided by D. So it's 3,438 times 8 divided by 1,500, and the answer is 18.34 minutes of arc. So when we use the formula for small check sizes, the answer is given to us in minutes of arc. To convert it to degrees, we know that there are 60 degrees. To convert to degrees, we know there are 60 minutes in 1 degree. And so 18.34 minutes gets divided by 60, which gives us an answer of 0.306 degrees. Alternatively, we could have used the large angle formula, which gives us an answer in degrees. And the large angle formula is equal to 57.3 times W, all divided by D. So it's 57.3 times 8, all divided by 1,500, which equals 0.306 degrees. And so you'll see that regardless of which formula we use, we come up with the same answer. Question number 2 asks, if the width of the screen is 30 centimeters and there are 30 checks on the screen, and the patient is sitting 1 meter from the screen, what's the visual angle subtended in minutes of arc, and what's the answer in degrees of arc? And so this is not really a trick question. You just have to think about it for a second. We know that the width of the screen is 30 centimeters, and there's 30 checks across the whole screen. That means each check is 1 centimeter wide. So the W variable is equal to 1 centimeter, which we have to convert to become 10 millimeters. The D, or distance variable, is the patient is sitting 1 meter from the screen, so it's 1 meter, which is 100 centimeters or 1,000 millimeters. So we'll start first with the small angle formula. Visual angle is equal to 3,438 times W divided by D. So it's 3,438 times 10, all divided by 1,000, equals 34.38 minutes. Our small angle formula gives us the answer in minutes. To convert to degrees, we know there are 60 minutes in 1 degree, and so we can divide our answer of 34.38 by 60 to give us an answer of 0.573 degrees. Alternatively, we can calculate degrees using the large angle formula, and this formula states that the visual angle is equal to 57.3 times W divided by D equals 57.3 times 10 divided by 1,000 equals 0.573 degrees. The units from the large angle formula gives us the answer in degrees. The units in the small angle formula is in minutes. And so this is actually a good way to use both formulas to check our work because they should give us the same answer. Question number 3 asks, if a stimulus subtends 9 degrees of arc and its width is 160 millimeters, how far away is the patient sitting? So we can use the same formula, we just have to manipulate the variables so we can find out what the distance, or d, is. So to help us decide which formula to use, we note that the angle is given in degrees, and so because it's in degrees, we know that it's the large angle formula. So we're going to start by writing down the large angle formula. So A equals 57.3 times W divided by D. And so we need to solve for D because we know what the other parts are. And so we manipulate our equation so that D equals 57.3 times W divided by A. And so D, the distance, is equal to 57.3 times 160 divided by 9 equals 1,018.7 millimeters. And to convert this, there's 1,000 millimeters in 1 meter. And so the answer is 1.018 meters. Question number 4 asks, if a stimulus subtends 55 minutes of arc and the patient is sitting 0.5 meters away, how wide is the stimulus? And so this is like the previous question where we have to manipulate our equation because what we're looking for is W, how wide is the stimulus? Now our first clue to which formula to use is that the answer in the question is given in 55 minutes of arc, which means we use the small angle formula. So we begin by writing down our small angle formula, which is A equals 3,438 times W divided by D. And so we manipulate our formula now to find out how to solve for W. And so we manipulate our formula and we find out that W equals A, the visual angle, times D, the distance from the stimulus, all divided by 3,438. So W equals 55 minutes of arc times 500 millimeters, or 0.5 meters, all divided by 3,438. And so W equals 7.999 millimeters, or 8 millimeters.